Here we have a SAT math problem. Okay, let's go to the question. If the diameter of a cylindrical jar is increased by 100% without altering the volume, by what percent must the height be decreased? Okay, so the question says the diameter is increased by 100% and the volume is not altered. And by what percentage the height has to be decreased? Okay, let me assume D as the original diameter and R as the original radius and H as the original height. Okay, when the diameter is increased by 100%, then this D will become 2 times of itself, that is 2D. When the diameter becomes 2 times of itself, then the radius also will become 2 times of itself, that is R will become 2R. Okay, now we have to find the percentage by which the height has to be decreased. Okay, let me assume the height has to be decreased by K percentage, that is decrease by K percentage. Okay, so here after the changes, the volume is not altered. That is, let me write the original volume and here let me write the new volume. So the volume of the original cylinder, the volume of the new cylinder will be equal according to the information we have without altering the volume. Okay, here we have R as the original radius and H as the original height. In that case, volume of the cylinder is 5 times R square times H. Actually, this is the formula to get volume of a cylinder. Since R is the radius, I have taken R for radius, and since H is the original height, I have taken H for height over here. Okay, now let's get the volume of the new cylinder, that is 5 times. Okay, the radius of the new cylinder is 2R. So at the place of R over here, we have to write 2R. The whole square, and height, that is the original height H, has to be decreased by K percentage. Okay, now let's get the new height over here. Let me do it separately. New height equals to, since the height is decreased by K percentage, we have to subtract this K from 100. Let me write it 100 negative K percentage times the original height H. Okay, here 100 negative K percent can be written as a fraction with denominator 100 times H. Okay, here 100 is a common denominator for this 100 and K. Now we can take this 100 denominator separately for this and this. Then I'm getting 100 over 100 negative K over 100 times H. Then we get 100 over 100 is just 1 negative. This K over 100 can be written as 1 over 100 times K times H, and here 1 negative. When I divide 1 over 100, I'm getting 0.01 K times H. Okay, so this expression represents a new height. Okay, here in the formula, instead of this H, we can write the new height over here. That is 1 negative 0.01 K times H. Okay, here pi R square H equals to pi times. Okay, here 2 and R are multiplied and we have the exponent 2 in common. Whenever two values are multiplied and there is common exponent, the exponent can be taken separately for this one and multiply the results. Then I'm getting 2 square times R square times 1 negative 0.01 K times H. Okay, now let me divide both sides of the equation by pi R square H. Let me do it. When we do so, this pi r square h will cancel out on the left side. Here pi will cancel out, r square will cancel out, this h and h will cancel out. Then the resulting equation is 1. That is, when I divide pi r square h by pi r square h, I'm getting 1 on the left side. On the right side, the value of this 2 square is 4 times we have this top, that is 1 negative 0.01 K. Okay, now let me divide both sides of this equation by 4. Then this 4 will cancel out. We get 1 over 4 on the left side. The value of this 1 over 4 is 0.25. On the right side, we have 1 negative 0.01 K. Okay, now we have to solve for K in this equation. Let me subtract 1 from both sides of this equation. When I do so, this 1 negative 1 will cancel out. When I combine positive 0.25 and negative 1, I'm getting negative 0.75 equals to negative 0.01 K. Okay, let me divide both sides of this equation by negative 0.01. Let me do it. So when I do so, this negative 0.01, negative 0.01 will cancel. This negative will cancel out. When I divide 0.75, 0.01, I am getting 75. On the right side, we have K. I got the value of K. The value of K is 75. Actually, we have assumed that the height has to be decreased by K percentage so that the volume will not be altered. Here we got the value of K, that is 75. So that is, the height has to be decreased by 75%.